Introducing the 2019-4 Schrödinger release. Let's take a look at some of the new features and enhancements. Starting in Maestro, we see a new and improved 2D viewer panel. Notable highlights include the ability to align 2D structures based on a reference. Here, the maximum common substructure can be highlighted. Structures can be manually reorientated. And one can easily display entry and atom properties, including the ability to display KPLS atomic contributions when launched from an auto QSAR model. The Style toolbox now contains a new option to choose an atom property to use as a color scheme. Here we can choose the desired property. In this example, we'll choose the AG score property, which was generated by the Protein Surface Analyzer panel, define a range or number of bins for this property, edit the atom colors for the values, and optionally save the scheme for future access. We see the new beta release of the new Induced Fit Docking method, IFD-MD. IFD-MD expands on the domain of applicability of structure-based drug design by incorporating the binding poses and pharmacophoric information of known binders as a template to help determine the binding pose of the ligand of interest, as well as running multiple metadynamics calculations to help assess the stability of the predicted poses. IFD-MD can even be used to structurally enable programs with homology models where sequence identity between the target and template can be as low as 40%. We also see a new panel for performing rapid fingerprint similarity searching across several large external databases using GPU technology. Here, any imported or sketched query molecule will be sent encrypted to a server where the search is run in a fraction of a second. In the FEP Plus panel, there are new settings to control how the panel interacts with the Maestro project. Here, you can choose to include entries in the workspace or select entries in the project when the corresponding nodes are selected, and whether to keep or remove the project entries for the nodes when the panel is closed. In the FEP Edge Analysis panels, over in the Rotatable Bonds tab, there is an option to normalize the plots so that the maximum value of the vertical axis is the same for all plots. In the FEP Advanced options, one can optionally perform ligand FEP calculations in vacuum to obtain relative solvation-free energies. Protein FEP results can now be loaded into the FEP Plus panel for analysis. Here, one gains access to representative structures and trajectories for the mutations. Speaking of trajectories, the Trajectory Player introduces new interactive plotting capability. Here, one can compute descriptors and measurements over the trajectory and visualize them on the right. And it is now also possible to include a second entry, for example, to be used as a reference when playing a trajectory in the workspace. In the Interactive Pose Prediction panel, it is now possible to load ligands directly from the workspace. The workspace ligand will automatically appear in the sketcher, ready to be docked. Over in Reaction Enumeration, both the Rios and Payne's smart filters have been included. This is in addition to Schrödinger's standard set of smart filters. In quantum mechanics, the Circular Dichroism Workflow panel now supports both vibrational and electronic circular dichroism Jaguar calculations. The Spectrum Plot panel can then be used to display the VCD and ECD spectra to help distinguish enantiomers. The Biologics Panels now supports the use of human-derived germline sequences. These are available in the antibody humanization workflow, such as here in the Antibody Residue Mutation panel, and during CDR grafting. And finally in KNIME, The Upload to Live Design node can update an existing model and supports selecting a protocol and Schrödinger version. These are just some of the new features in the 2019-4 Schrödinger release. As always, for more information, please visit schrödinger.com/new features.